At 1:23 a.m. on April 26, 1986, an operator in Chernobyl reactor number 4 pressed the emergency shutdown button. This button was designed to stop the nuclear reaction inside the reactor. But this time, it became the detonator. In the next 4 seconds, the reactor's power surged to 100 times its normal output, triggering an explosion powerful enough to blow the reactor's 1,000-ton lid through the roof.
Припять, третий и четвертый блок горит крыша в результате аварии взрыва.
Увидела, давай. Так уже подтвердили?
Не подтвердили, авария там произошла у них. Это диспетчер Припяти сказала. Пожарная охрана. Алло, Иванков? Да. Значит, вы выезжаете в Припять? Алло? Да, я слышу. На атомную станцию выезжаете. Там третий и четвертый блок горит крыша. Алло, Полесская? Да. Вы, значит, выезжаете на атомную станцию, там горит крыша третьего и четвертого блока.
But this wasn't any random accident. It was the result of 4 bad decisions made over 14 hours. This is the story of how a classified report from 1975, a skeleton crew, and a single button designed to save a reactor combined to create the worst nuclear disaster in human history. In the spring of 1986, Pripyat was a model Soviet city. Built to house the workers of the Chernobyl nuclear power plant, it was home to nearly 50,000 people, and the average resident was just 26 years old. It had a cinema, a sports center, and a brand new amusement park. The amusement park, which was scheduled to open on May 1st, 1986, never opened because the reactor that powered the city had already begun its countdown. The Chernobyl nuclear power plant ran 4 RBMK-1000 reactors, a Soviet design considered to be reliable and efficient. It was a symbol of national pride. And unlike most nuclear reactors, the RBMK used graphite blocks to control the nuclear chain reaction, while ordinary water acted as the coolant. That design gave the Soviet Union something incredibly valuable. It could generate electricity while also producing weapons-grade plutonium. But unfortunately, that same design had a flaw, a dangerous one. And the shutdown system designed to protect against that flaw also had a flaw of its own. The engineers at the Kurchatov Institute knew about both flaws. They documented and studied them for years. Yet, the operators of Reactor 4, who were in the control room on the night of April the 25th, were never told about it. The story of how that information was kept secret from them starts 11 years earlier, in a city 1,000 kilometers to the north. On November 30th, 1975, the engineers at the Leningrad nuclear power plant were carrying out what should have been a routine reactor shutdown for maintenance. The plant had the same RBMK-1000 design. So in the process, a fuel channel ruptured and radioactive materials escaped into the atmosphere. Fortunately, the incident was contained and investigated internally by the Soviet nuclear authorities. The investigation revealed something dangerous. There was a fundamental instability in the RBMK design called the positive void coefficient. Here's what that means. In most nuclear reactors around the world, if the coolant water begins turning into steam, the nuclear reaction slows down so the reactor can cool itself. It's a built-in safety feature. But this RBMK did the exact opposite. As the water turned into steam, the reactor sped up. More heat made more steam. More steam made more power, and more power made more heat. It was a loop with no natural stopping point. When the Soviet nuclear engineers at the Kurchatov Institute understood the flaw, they raised concerns internally. But since the RBMK reactor was a symbol of Soviet achievement, admitting the design flaw would mean that the Soviet nuclear program was built on a compromised foundation. So the reports were classified and the operators were not informed. The second flaw was arguably more dangerous, but it won't be clear until the final decision of the night. For now, what matters is that the people about to run a safety test on Reactor 4 didn't know their reactor had a documented instability that could turn a shutdown into an explosion. And the test, meant to begin on the afternoon of April the 25th, was delayed. Over the next 14 hours, 4 decisions were made, with each decision pushing the reactor one step closer to disaster. At 1 p.m., the operators began reducing the reactor's power for the safety test. The test was simple, and the goal was to know if the turbines could keep the emergency water pumps running until the backup generators started. With the first 2 attempts failing, this was the 3rd attempt at the test, so there was pressure to get it completed. But just as the test was about to begin, the grid controller in Kyiv called. Ukraine was experiencing high electricity demand, so Reactor 4 was ordered to stay online. After the call, the test got delayed by 9 hours, and the day shift crew who understood the reactor's current state and prepared the test went home. By night, a new crew arrived. They were less experienced and met the reactor in a condition that they didn't set up. At 12:28 a.m. during the power reduction process before the test could begin, something went wrong. The reactor's output dropped to roughly 1% power. At this level, a byproduct called xenon was flooding the core. Xenon absorbs neutrons, so it was strangling the chain reaction from the inside, poisoning the reactor. There was only one safe option. They were to shut the reactor down, wait 24 hours for the xenon to decay, and start over the next day. But they didn't wait. To force the power back up, the operators began pulling the control rods out of the reactor core. Standard regulations required at least 30 rods in the core at all times, but they left only 18 rods after pulling. Some accounts say as few as 6 rods were left. They also disabled the automatic shutdown systems which were designed to stop the test if the conditions became dangerous. Anatoly Dyatlov was the deputy chief engineer, and he oversaw the operation. When a junior operator expressed concerns about the instability, Dyatlov dismissed him and ordered that they proceeded with the test. Then at 1 a.m., the reactor was running at roughly 200 megawatts. At this point, it was low, unstable, and stripped of nearly every safety system designed to protect it. There was still time to shut the reactor down and postpone the test, but Dyatlov ordered them to proceed. And when things went wrong 23 minutes later, the operators would reach for the one thing they believed could save them: the emergency shutdown button. What they didn't know is that the button had a flaw of its own. At 1:23 a.m., the test finally began. The operators cut off the steam supply to the turbine, expecting it to keep spinning just long enough to power the emergency water pumps. But as the turbine slowed, the pumps also slowed. Less cooling water flowed into the reactor core, causing the remaining water to heat up and turn into steam. Under normal circumstances, that wouldn't have been a problem. But Reactor 4 wasn't normal. The flaw from Leningrad in 1975 was now visible. As more steam formed, the reactor didn't slow down. It became more powerful. The more steam it produced, the faster the nuclear reaction grew, creating a deadly chain reaction that was now slipping out of control. 40 seconds later, the shift supervisor noticed the surge and ordered the emergency shutdown. And on his command, the AZ5 button was pressed. For a brief moment, everything appeared normal as the control rods began descending into the reactor's core. It was supposed to shut the reactor down. Instead, it activated the reactor's deadliest design flaw. The control rods were fitted with graphite tips. So as they descended into the core, those tips displaced cooling water, spiking reactivity before the rods could begin absorbing neutrons. The power surge became worse, and the thermal output hit 100 times the reactor's rated capacity, causing the fuel rods to fracture and turning the superheated water to steam. As a result, what followed was 2 rapid explosions. One was steam, the other was likely nuclear. The blast launched the reactor's 1,000-ton lid through the roof, releasing burning graphite and radioactive materials into the environment. The radiation released was 400 times what Hiroshima released in 1945. The following morning, residents noticed a metallic taste in the air. With radioactive materials in the environment, children still played outside, and couples walked along the bridge, overlooking the plant to watch the strange blue light. There was no official warning yet, and Pripyat was not evacuated for 36 hours after the explosion. On April 27, 1,200 buses arrived. Residents were told to pack for just 3 days, so they left behind their homes believing they'd soon return. But most never did. The Soviet government initially told the world nothing, until the Swedish monitoring stations, which were over 1,000 kilometers away, detected the radioactive cloud drifting across Scandinavia and raised the international alarm. Within weeks, the Soviet state presented its official explanation. They called it an operator error and also stated that the crew's recklessness had caused the disaster. Someone had to take the blame for this. So, the deputy chief engineer Anatoly Dyatlov was sentenced to 10 years in prison. He ended up serving just 4 years. And while the operators paid the price, the engineers who knew about the reactor's design flaws long before the disaster occurred were never charged. On the other hand, Valery Legasov, the chief scientist on the investigation commission, fought internally for the truth. He presented findings to the International Atomic Energy Agency in Vienna and argued behind closed doors that the disaster wasn't just about a crew in one night, but it was about a system that made it impossible to admit failure. Yet, no one listened to him. In April 1988, Legasov hung himself. He left behind cassette tapes documenting everything the Soviet government had buried. Those tapes remain the most detailed first-hand account of what the Soviet government hid and why they hid it. The Chernobyl exclusion zone will remain uninhabitable for 20,000 years. More than 350,000 people were permanently displaced in the aftermath of the disaster. But while the evacuation numbers are well documented, the death toll remains one of Chernobyl's greatest controversies. The Soviet figure was 31. The World Health Organization estimates the death toll to be around 4,000. Independent studies say it's above 29,000. The safety test that triggered the Chernobyl disaster took 36 seconds. But the design flaw that made it possible was documented 11 years earlier. The question isn't whether the operators made mistakes that night. They obviously did. The real question is, what happens when the people who know the danger decide that admitting it costs more than the danger itself? That question didn't die at Chernobyl. It's still being asked around today.